So this is a sample problem for doing a two-step unit conversion. And so when we do unit conversions, we do one of two things. If we're converting temperatures, we use formulas, and anything else that we're converting, we use conversion factors, and conversion factors are fractions. So in a two-step problem, we could be using one formula and one conversion factor, or most likely what we're going to be doing is multiplying a number by two conversion factors. So let's see what we've got going on here. The question's about a military jet. It's cruising at an altitude of 12 kilometers and traveling at a speed of 1800 kilometers per hour. Now, the 1800 kilometers per hour captures my attention because that is a conversion factor. It says that I travel 1,800 kilometers every 1 hour, or alternatively, I could write that as in 1 hour, I travel 1,800 kilometers. And then it says I'm going to burn fuel at a rate of 58.4 liters per minute. So again, that's a conversion factor, so that's really interesting. So I'm always kind of taking note of that. So it looks like, remembering that this is a two-step problem, these are going to be my two conversion factors. All right. Now it says calculate the amount of fuel that a jet consumes on a 1,600 kilometer mission. So doesn't really tell me what the units that has to be in, but it's going to end up in liters, right? So what I've got to do is take 1,600 kilometers, which is not a temperature, multiply it by one or more, or at least two conversion factors, and turn it into liters, right? Because liters is a measure of volume. So the first thing that I'm going to do is turn my kilometers. What can I do with my kilometers? I'm going to turn my kilometers into hours. So 1 hour, 1,800 kilometers. And then I'm going to turn my hours into minutes. And then bingo, now I can apply this guy, 58.4 liters for every 1 minute. So how did I know how to do that? All right. So what I knew is the only thing that had amount of fuel in it was this conversion factor here. And I needed to multiply that by a time expressed in minutes. So my strategy went like this. I was going to take kilometers, then I'm going to turn that into minutes, and then I'm going to apply that final conversion factor, which is going to turn it into liters. But my conversion factor that relates kilometers and time has hours in it. So I actually had to kind of take a little detour. I had to go from kilometers to hours, and then I could go on to minutes, right? So that's it. Now, I don't have to do any of the math here. I just have to enter in these three conversion factors, and I know I got it right because look, there it is. All right? And that leaves liters behind. Okay, all seems good, huh? So here is another problem of this type where we're going to be doing a two-step unit conversion. So we're looking for two conversion factors, right? So it says it takes 2.45 joules of heat to raise the temperature of object A by 1 degree Celsius. So that's a conversion factor. It's saying if I put 2.45 joules of heat in, the temperature of A will go up by 1 degree Celsius. Or another way of saying that would be for every 1 degree Celsius that I raise the temperature of A, I have to put in 2.45 joules. So that's one conversion factor, and we should make it clear that this belongs to object A. So that's the first one, and then we've got another one. It says it takes 5 joules to raise the temperature of object B by 1 degree Celsius. So for every 5 joules you put in, you raise the temperature of B by 1 degree Celsius, or for every 1 degree Celsius that you want to raise the temperature of B, you got to put 5 joules of energy in. So we've definitely got two conversion factors here. Now it says, suppose A and B are brought into contact and A is initially hotter. So what do we know when two things come into contact? We know that heat spontaneously moves from the hotter object to the colder object. You know this, if you put your hand on the hot plate on your stove, you don't go, oh my goodness, my hand is getting so cold, so much heat is flowing out of my hand into the boiling hot stove. What actually happens is you go, ouch, my hand got hot, because heat flowed from the hot stove into your cold hand. That's just kind of how it works, right? So A is going to get a little cooler and B is going to get a little hotter. And then it says A is seen to cool down by 14 degrees Celsius. So if A goes down by 14 degrees Celsius, according to our conversion factor, that's the same as saying that the amount of heat that is lost by A will just be 2.45 times that. Alright, so that's how much heat is lost by A. Now where is that heat going? Well, it's going into B, right? It's going to go into B, and as it transfers into B, it's going to make the temperature go up. It's going to make the temperature go up according to this conversion factor, which says that the temperature of B will go up by 1 degree for every 5 joules of heat that you put in. So it's not going to go up by 14 because, well, you know that it takes more heat to raise the temperature of B. So let's have a look at our units here. There we go. They all cancel out. And it's going to give us the temperature change in B. So these are the two conversion factors that we have to multiply by in this case, right? So it's going to be 14 degrees Celsius times by 2.54 joules for every 1 degree Celsius times by 1 degree Celsius for every 5 joules, and that's going to just cancel on out, and all that's left is degrees Celsius, so we know we got it right. So you just have to put your expression in to solve this problem. You don't actually have to do the math. Okay, alright, so that's two of those guys, and I hope that they make sense.